we have discussed, just let me tell you in brief. We discussed about the data types. I mean, if you are interested in analytics part, if you want to start your career or switch to career career in analytics, then obviously you should know what type of data are there. Okay, so we discussed the data types and then the frequency and the chart type. And last time we discussed about the central tendency and dispersion. These two topics are very, very important because when you will start analyzing data, this descriptive statistics part is going to help you out to understand the structure of your data set and to clean your data set. Clean means suppose you are having a huge number of data. So different type of observations you are having. Okay, and if any observation is not compatible with others, so you need to take out of that particular data point, okay, or observation from your data set. So which one you should take out or why you are taking out, these things we have discussed in last 2 days. Today I'm going to discuss another very important topic, skewness kurtosis. Although it is not used frequently, but you should know the concept and where you can use it, you should know it, so that if it is needed you can apply it. Okay, so dispersion. Okay, when you are doing this skewness and kurtosis, you should know what is dispersion or what is variation. Now just let me show you this one. If you are having two data set, okay, this series 1 and series 2, and if anyone asks you that which one is better, then the answer would be series 1. Why is it so? Because you can see for both the series the average median are same, okay, but this for this series 1 you can see, Sajid, you also can't hear me? Shruti, Jishan.
I'm able to hear you.
You can hear me.
Matuja, it's fine. Perfect now.
Okay, I think Vartika is having some audio problem, so let her know, please, because she can't hear me.
Okay.
Okay, I'm right. Okay. I think you had some problem in audio connection, Vartika. Okay, so what I was telling you, see here, you are having two series of data, okay, observations. And for both the series, you are having same average and same median. So if you only consider this average and median, so you can't differ, right? Both the series are equal. You will consider it. But it is not the case. If you see the observations or the data points, it's 30, 32, 36, 38, 39. So they are very close to each other, right? And here you can see the first observation is 4, then it is 19, then it is 36. So they are not compatible. They are not very close to each other, not very consistent. It is actually termed as variation. So in a data set, if you are having high variation, that is not good for your model. Or suppose you want to do any analysis and the variation is very high or the standard deviation is very high, which is a measurement of variation, then the sample is not so good. And if the sample is not so good, what does it mean? That the conclusion or the decision you are going to take on the basis of this data set, it might be wrong, or you will not get a proper solution of a particular problem. So that is why we always want to check what is the standard deviation, or excuse me, or what is the skewness kurtosis of a data set. Okay, it's telling you about the nature of the or the structure of the data set so that you can understand your data set is good or bad. So dispersion was, is a very famous concept to check the variation within the data set. Another measurement is there, that is skewness and kurtosis. Dispersion part we discussed last day, so you can go through the videos, and if you are having any queries, so next day you can ask me. Okay, today we are going to discuss the skewness and kurtosis part. The main objective is to find out whether the data set is having a larger variation or a very small variation. So if large variation is there, that means it's not a good sample and it might lead you to a wrong conclusion. That you have to keep in your mind. Now, when we are talking about skewness, what does it mean? It means it is used to denote the extent of asymmetry in the data. Now, when you are having a data set, you have to check whether it is symmetric or not. Again, a new word, right? Symmetric. What does it mean, symmetric? If a data set is symmetrical or symmetric, then the mean of that data set is equal to median is equal to mode. This mean, median, mode are the what? Are different types of average. Okay, when we are having a data set and we want to calculate the average of that data set, we are having three options. We can use mean, we can use median procedure, or we can use mode. So these are the three approaches by which we can measure an average of a given data set. Now, if a data set is symmetrical, that means its mean, following up the mean approach, the average what we are getting is equal to the median approach is equal to the mode approach. Okay, so three approaches we can consider, and from three approaches only we are getting same value. So then we are calling that data set a symmetrical or a symmetric data set. If it is not the case, then we are calling the data set as asymmetric. Okay, when the average what we have got from mean approach is different from median and mode, then we are calling it a symmetric data set. Okay, now this skewness is used to denote the extent of asymmetry. Okay, now symmetrical distribution means mean is equal to median is equal to mode, and asymmetrical distribution means they are not equal. Now, you can see we have the height and with it we have the frequency. Okay, so the value we are measuring along with the horizontal axis and the frequency we are measuring along with the vertical axis. Now what you can see, if you plot these values, suppose for the first one is 114 centimeter, then 115 centimeter, okay, 160 centimeter, 170 centimeter. So for this, suppose for this 117 centimeters, you can see the highest frequency we are having. Okay. Now, if it is a symmetric in nature, if suppose the distribution is symmetric in nature, how does it look? It looks like this one, this particular diagram. You can see here. In middle, we will have the highest frequency part. But here, if you compare this graph with this one, this particular one, not this one, this below one, this lower part, Then you can compare. Here you can see that in left side you are having the highest frequency and then it starts decreasing, right? And here you can see just the opposite. I mean, in middle position we are having the highest frequency. Okay, so it is skewed. This one is skewed and here it is not skewed. Okay, now in this case also you can see, if you start from here, in rightmost area you are having the highest frequency. Again, if you compare with this one, you can understand that in middle position the average is not taking into the, I mean, it's not taking the place, okay, in the middle position. So that means it is also skewed. Naturally, when you will analyze your data, you are not going to plot this diagram. Okay, yes, obviously it's always better to visualize your data so that you can get a better understanding, but it comes after means when you will run a code in R, it's not going to show you it graphically. You obviously use some package to get it in the get the visual part, then it will give you some graph so that you can visualize the dataset structure. Otherwise, what it will give you some values. Okay, the mean value, the median value, and the mode value. And then looking at these values, you have to compare the skewness is there or not. And if it is skewed, it is positively skewed or negatively skewed. It's always better to have a skewness close to 0. Okay, let me explain. So skewness means variation is there. It's a in very simple term, just try to understand. If it is positively skewed or it is negatively skewed, it means variation is there. If zero skewness is there, that means no variation is there. That you have to keep in your mind. Now, how will you understand that it is skewed or not, or it is positively skewed or negatively skewed or not? That I'm going to tell you now. If you see, you can get the mean value, the median value, and the mode value of a data set. Now, if you see, the mean value is the highest one, median is taking the middle position, and mode is the lowest one, mode's value. Okay, then you can say that the distribution is positively skewed. Okay, if you see that mean is taking the minimum value and mode is taking the highest value and median again is taking the middle position, then we are calling it negatively skewed. And zero skewness means when mean is equal to median is equal to mode. It's always better to get zero skewness. Okay, this one. If you plot the graph, if you plot this at this extreme points, you will get a curve like this. This is a bell-shaped curve. This is a standard one. We are calling it normally distributed or symmetrical distribution. This middlemost one, this point is actually means value. So mean is equal to median is equal to mode. Okay. So this is what your zero skewness. So what you will get some value and you have to compare it. If you see the mean is taking highest position and then its median's value comes and then mode, then it is positively skewed. Otherwise, the opposite one is called negatively. If three of them is having same value, then we are calling it zero skewness. Okay. It's always better to have a zero skewness, but what you have to compare that it should not be the skewness, even if you are getting skewness, it should not be very large. Suppose you are getting 2.2 or 3.2, it means it is more or less close to 0, so you can consider it. But suppose you are getting skewness value as 10 or 20, it means the fluctuation within the sample is very high. Okay, so it might lead you to a wrong conclusion. There is no hard and fast rule what should be the actual value of skewness, but always remember close to 0 better for your model. Close to 0 means variation is less. Variation is less means your sample is good and you will get a better conclusion or a correct conclusion from your data set. So have you got my point, guys? Okay. It is also used to understand the sample structure, how much variation it is. Okay. So kurtosis is a measure of distribution's peak, which means how much of distribution is centered on the distribution mean. So what actually is doing, you are plotting the data and it is following up some distribution. Okay. Different type of distributions concept are there. Just understand that distribution is a nature. What type of nature it is having? Okay, suppose we are having so many type of board exams. Is West Bengal, it's Delhi board. In Delhi board we are having ISC, CBSC. So different types of distribution is there. The students coming from ISC, the students coming from state board, the student coming from CBSC board, different type of boards they are coming from. So they are following up some kind of structure or some kind of syllabus structure, right? So here also, when we are having a data structure and they are having some distribution, either they are from the T distribution or they are from the normal distribution or uniform distribution. So different types of distribution is there. So what type of distribution is it? We always want to get a normal distribution. Why is it so? Suppose if I say like for joint entrance or for suppose the medical. So which board is the best one? Because the syllabus structure matters, right? So suppose I consider CBSC. No offense to West Bengal Board or ISC. If you consider the, the AIEEE or that type of or IIT structure, so you can relate with your CBSC. I heard that so many people coming from CBSC, they can relate. It becomes very easy, if you are coming from CBSC background. So, here also for our analysis, we always want to get a normal distribution because it's a standard one. Standard one means when you will develop some model, you have to have some assumptions, okay, and that has to be fulfilled. So these assumptions are mainly based on the normal distribution. Means if your data is normally distributed, then only it's possible to develop that kind of model and to satisfy those assumptions. Okay, so that's why we are considering normal distribution as a standard one. We always want to get a normally distributed data set. That's all. So here also, if you are plotting the data and you want to see the distribution, now the kurtosis is telling about the type of distribution what you are having. Okay, whether it is T distribution or normally distribution or uniform distribution. Okay, now this is the graphical presentation. This one is called positive kurtosis. This is termed as leptokurtic. If you are having normal distribution, we are calling it mesokurtic. If we are getting this type of data set, we are calling it negative kurtosis, and the name is platykurtic. When you will run a code, the system is not going to give you any diagram like this. Okay, so this is only for understanding. It will again give you some value, and on the basis of that, you need to understand whether it is positive kurtosis or normal distribution, or it is negative kurtosis. Now see here, when a distribution kurtosis coefficient is greater than 3, actually, when we were discussing the skewness part, I told you it's 0 means its value. If you are getting 0, it means it is symmetric, right? 0 skewness is there, so it is normally distributed. If you are getting positive skewness, it means there you are getting mean as the maximum and mode is minimum. If you are getting negative skewness, it means the mode is taking the highest value and mean is the lowest one, right? So in this way, looking at that value, you can understand whether it is positively skewed, negatively skewed, or 0 skewness is there. Here also, in similar way, there is a value. Now here you will not consider 0. If it is normally distributed, then the value should be 3 or close to 3. Okay, you can see here this 3. Value 3 means it is the standard one. If you are getting the value of kurtosis, which is equal to 3, 3.1, or suppose 2.999, so very close to 3, so it means the data structure is more or less normally distributed. Okay, if you see the value is more than 3, means it is positive kurtosis. It is leptokurtic. And if it is less than 3, and obvious less than 3 means suppose it is 1 or less than 1, so it is what? Negative kurtosis. Now the point is that if it is positive kurtosis or negative kurtosis, what does it mean? It means positive kurtosis means it's not following up the normal distribution. It is mainly following up the t distribution. And if you are getting negative kurtosis, it is actually following up some uniform distribution, not the normal distribution. And what I told you, we always want to get a normal distribution, because suppose you are going to develop a linear model. Okay, when you will do some software, you will do these things. So linear regression model is based on the assumption that the data is normally distributed. Now, if the data set is not normally distributed, it means it would not be possible to develop the linear regression model. Okay, and then you any other measurement, or what you can do, you have to transform your data set, and again you have to test whether it is normally distributed or not, and then you can develop the model. Okay, so looking at this structure, you also can understand that the data types you are using, that is normally distributed or not, and then you can develop your model, and again you can check the assumption that whether it is normally distributed or not. So 2 times you can check it. So in this way, during this skewness kurtosis part, you can understand the structure of the data set. I mean, how much variation is there, or what is the possibility that the data set is going to be a normally distributed, or might be it's following up the other type of distribution. Okay, and obviously you will not get any diagram, a value you will get, and you have to compare that. So for kurtosis, if you are getting the value close to 3, it means it is normally distributed. Otherwise, it is positively kurtosis, means it is t distribution, or negative kurtosis you are getting. And for skewness, if it is close to 0, variation is very less and better for your model. Plus, it is normally distributed. Otherwise, you are getting a positively skewed and negatively skewed. Obviously, there is no hard and fast rule. What would be the value of positively skewed and negatively skewed? What you can consider, but obviously, it's always better to have a value close to 0, because that means the variation is less, the data points are normally distributed, and you might get a better solution for your data set. That's all. So this is how you can use this skewness and kurtosis part. Have you got my point, guys? Okay. Others, please answer me. Okay, great. Thank you, guys. Okay. Now let's start our new topic. It's correlation. It's very simple, and I think you people know what is it. Correlation means, suppose we are having two variables. Yes, Vasudhev, ask me.
In practical, hello,
Mm-hmm.
can you hear me?
Yes, 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 yes,
In
Vasudhev.
practical, most of the cases we will get the data which is not normally distributed. Mostly, I will get some skewed data. The dispersion will
Mm-hmm.
not be ideal.
Mm-hmm.
So,
Mm-hmm.
let's say I do have a data set where I have some 10 to 15 x variables and a y variable. So
Mm-hmm.
my x variables are mostly, let's say, 5 to 6 variable are not normally distributed. So in that case, what measure I should take
Mm-hmm.
to, as you said rightly, that regression model will not be that much
Mm-hmm.
effective if I will
Mm-hmm.
run a regression on that kind
Mm-hmm.
of data set. So what kind of statistical things you
Measurement we can take, yes, to
we
resolve the
take?
problem. I got your problem. So let me tell you, Vasudhev. See, we are having different type of measurements. Okay, if you are looking at this skewness cartridges, that's not all. You have to check the SD and the mean median outliers are there or not. And we are actually not going to drop any variable in the initial stage. Okay, suppose looking at this skewness and cartridges, you are getting like for some variables you are not getting, it is normally distributed. What we are going to do, we are going to develop our model. Okay, because it might happen that the variables what we are not following normal distribution, or suppose it is not it is having a very high skewness or positively kurtosis. Okay, it might happen that when you are developing a model you find it insignificant. Insignificant means you are testing whether the variable is affecting your dependent variable or not. If you find that variable is not affecting at all, you are going to drop it. Okay, so and then that's why I told you that initial stage you have to understand the structure of your data. Okay, and what is the possibility that the data set would be a normal distribution or not, you can get an idea. But at this stage you can't drop any variable. Okay, when you will start developing a model, you have to follow up some steps where you need to find out the variables which are actually having a significant impact on your dependent variable, and the insignificant variables you need to drop out. After doing that, when you are having a set of significant variables, again you need to check the normal distribution. Okay, that time if you find that no, it is not normally distributed, see, in this way we can change the form, because if then what I can suggest that the problem of homoscedasticity or normal distribution can be solved if you increase the size of the data set, because it is expected that when you are having a large number of data set, it should follow up the normal distribution. So you can request your client to give you more data, okay, and then again you need to, yes Vasudev, right, so large number, you know it, so you have to increase the size of the data set. But I would tell you, in the initial stage you are not going to take any decision that which variable you are going to drop out. It's, you are getting an idea what type of data structure you are having, so that if you get any wrong conclusion or bad conclusion, you can suggest your client to increase the size of the data, or you can tell your client that, see, my data set is not good, so the conclusion what you are we are getting, it's not good, or it can't be generalized. Okay, so that's why you have to understand this structure of the data, and you have to use the descriptive statistics as well. Okay Vasudev, I hope you have got your answer, right? Okay, yeah, welcome. Okay, now let's come to the regression part. Okay, so we were talking about the correlation. So what is correlation? If suppose two variables we are having, my favorite example is price and demand, and everyone knows if price increases, demand decreases, right? So that means these two variables are related with each other. Now you might have different types of variables, okay, and you want to check whether they are related with each other or not. When you will develop a model, you can check it with your dependent variable and with your independent variable, right? So what is dependent and independent, I'm going to discuss in my next topic, regression. So for the time being, let's discuss the correlation part. Now correlation is also a three types. One is if they are negatively correlated, and another one is positive correlation, and third one is no correlation. Okay, examples are also given over here. For the first one, we are having hair and time. So as time passes by, hair starts falling. Now nowadays it's not depends on the age, let me tell you, okay, but you know, the weather and all those things, and that's why we start losing our hair anyway. So jokes apart, so naturally when we are growing old, so we start losing our hair. So time period is increasing and hair volume is decreasing, so they have a negative relationship. Now height and weight, so when height is obviously increasing, weight is also increasing, it is expected. Some unnatural or some exceptions might be there, but we are not going to consider those exceptions. Generally, if height is good, weight should be a standard one, otherwise it will be overweight or underweight problem. Okay, next one is age and eye color. So is there any relationship? Obviously no. So that means we are not having any relationship when we are considering age and eye color. So no correlationship. And now if we plot this, you know, data set, and we are considering two variables for this one, height and weight, we have got a line like this. It is positively sloped. Next one is, it is negatively scored for what? Hair and time. And age and eye color, as because there is no correlation, we are getting a scattered one, because we can't get any pattern, whether it is positive or negative. We can't find any pattern in our data set. So that's why we are calling it, there is no correlation. Okay. having five, I mean, A, B, C, D, E, 5 examples. You have to tell me what type of relationship they are having. The first one is ages of husbands and wives, how they are related and whether they are related or not. Shoe size and intelligence, insurance companies' profit and the number of claims they have to pay, years of education and income, amount of rainfall and yield of crop. So I'm giving you 2 minutes to complete it and answer me what type of relationship they are having. Please write down your answer all together, means A, B, C, D, E, not separately. Okay? And then I'm going to discuss. Guys, do it please. Okay, Hari Krishna has already given his answer. Ashish, what is CCBAA? You have to tell me that which one is positive and which one is negative. Okay, okay. Okay. Interesting answers I have got. Okay, Vasudev. Okay, positive, then inverse. Okay. Jishan, INT means inverse. Okay. Positive, 0, negative, positive, positive. Okay, Vatika. Okay, independent means zero correlation is there. Okay, I got it. Okay, guys. Good one. Now, let me tell you. Guys, so ages of husbands and wives. No correlationship or negative correlationship. It's not right, right? So, if anyone is not getting divorced, then when the age of husband is increasing, so obviously his wife is also growing old, right? So it moves in same direction, right? If the condition is condition applied, if anyone is not getting divorced and is getting married with younger people, anyway, so when the age of husband is increasing, obviously wife's age is also increasing, so they have a positive relationship because they are moving towards the same direction. Okay. Shoe size and intelligence, negative correlation? No, obviously not. Independent, yes, obviously, right? So zero correlation. One of my students just told me that see, there is a positive relationship. So I told him my shoe size is not so big. That means you are insulting me that I'm not intelligent. Anyway, so intelligence is having no relationship. Okay. Insurance companies' profit and the number of claims they have to pay has a negative correlation. Why is it so? Because if they have to pay more number of claims, what they have to do, I mean, what is going to happen? The revenue is going to decrease, so that means the profit would be decreased. So that's why insurance companies profit and the number of claims they have to pay, they have a negative relationship. Next is years of education and income. Someone has answered me plus minus, okay, or it's just dash anyway. So if you are considering, okay, the students is not getting failed in a same class, so that means if more years a student is spending in education, more skilled he is getting or she is getting, that means a good package, a better package is waiting for him or her, right? So years of education and income is having a positive correlationship. In similar way, amount of rainfall, I consider here the adequate amount of rainfall, not the excessive one. Okay, so amount of rainfall and yield of crop, these are also having a positive correlation. So ages of husbands and wives positively correlated. Shoe size and intelligence, no correlation. Insurance companies profit and the number of claims they have to pay, negative correlation. Years of education and income, positive correlation. Amount of rainfall and yield of crop, positive correlation. Okay. Now, here also in correlation, one very famous term is the correlation coefficient. It is depicted by small r. Small r means correlation coefficient. Okay. R's value lies within -1 to +1. Okay, so one value is -1, then R, and again +1. Okay, so that means you can have, if the value, if you are getting a correlation coefficient which is close to -1, it means they are perfectly negatively correlated. If you are getting something close to +1, that means they are more or less perfectly positively correlated. And close to 0 means what? No correlation is there. Have you got my point? So R is there, that is correlation coefficient, and R's value lies between -1 and +1. If it is close to -1 or +1, they are highly correlated, or the degree of association is high. If it is close to 0, it means no such correlation is there. Got my point, guys? This thing you have to keep in your mind. Okay, great. So everyone got my point? Yes, right. Right, Harshan. 0 means there is no correlation exist or no relation exists. Okay, we naturally don't get +1 or -1. I mean, it's very, I mean, exceptions that you will get perfectly correlated, but obviously you will get close to 1 or close to -1. It means they are highly correlated. Okay, and if it is close to 0, no such relationship is there. Now, this thing you have to remember, and this is how we do. We use the correlation, but not in our initial stage. See, when you will get a data set, let me tell you, sorry, you are going to check the data set structure. Till this skewness and kurtosis, this descriptive statistics part is used in our initial stage. After that also we can check it individually, but in the beginning we use these descriptive statistics to understand the structure of the data, to find out some extreme values which are not compatible with other set of observations, and we deal with those part. We do the missing value treatment. If suppose in your data set some values are missing, how to resolve the problem or how to deal with that part. For these things we use these concepts, this from the data types till this skewness and kurtosis. This correlation part we use when we start our modeling part, because that time we need the dependent variable and the independent variable in a form, and we can check our correlation part over there so that we can understand that which variable is more relevant to keep and which is not so important. Okay, so this correlation regression part we are going to use in our developing our model. But till this skewness and kurtosis part is mainly used in your initial stage. And let me tell you, the model development is not going to take much time. The most of the time you have to spend to understand the data structure, the industry, to clean your data. Okay. For these activities, this descriptive statistic plays a vital role. Without it, you can't move ahead. Okay. Now we are done with this correlation part. Now the very important part we are going to start, that is regression. Okay. Now the point is, if you want to know, if you suppose you have two variables, pseudo correlation actually Vasudev, actually I can do that, but not now. In next class we can do it, okay, because we have to cover up some more topics. I can do that one, okay, for you, but you have to wait for another one day. Thank you so much, Vasudev. Okay, now what we are going to discuss now, just a second. So if you want to know, suppose you have two variables, price and demand, and you have got the idea that, see, they are negatively correlated using your correlation coefficient. You get to know that one. But now another question arises, like if price increases by suppose 5%, the demand obviously it will decrease, but by how much? Means the magnitude of change. Another question is that if the price of the commodity now it is 20, and now it, suppose after some time it becomes 500. Okay, I'm going to charge 500 for my product. So what would be demand? Okay, what would be the demand? So I want to predict the value. Can you tell me that using that correlation coefficient concept, can we answer these two questions, that the magnitude of change and the prediction of the value? Guys, no, right? Because correlation coefficient is only, Hassan, it's not yes, it's actually no. Correlation coefficient is telling you about whether they are strongly correlated or not. Okay, so that thing only we can understand from our correlation coefficient. But if one of those variables is getting changed, how it's going to affect, by how much the other variable will be changed, Or if the price is 500, what would be the demand for my product? That we can't answer from this correlation coefficient part. Right, Hassan? That is the thing I am telling. Okay, it's telling you the degree of association, means whether they're related or not. If one is changing, another one would be changed, but how much? That we can't answer using that correlation of coefficient part. That's why we need this regression. Okay, so regression analysis is used to predict the value of a dependent variable based on the value of at least one independent variable. So when the price is 500, the demand would be what? Or if price increases by 1% or 2%, the demand would be decreased by how much? These answers we can get using this regression concept. That's all. Now here you have got two more concepts. What is dependent variable? Another one is what is independent variable. Now dependent variable means the variable we wish to predict, or the variable for what we want to know the magnitude of change. In our example, it is demand, right? We want to know what would be the change in our demand, what would be the demand for the product if price increases by this much, right? So in our example, demand is the dependent variable, and independent variable which is used to explain or predict the dependent variable. So in our example, price is the variable used to explain or predict the dependent variable. Okay. Now, this regression part is expressed in some equation form. Okay, and the equation is following up this straight line equation. This is the equation, regression equation. Suppose quantity is y is equal to what we usually get in our straight line equation, c plus mx, right? X is our independent variable, m is our slope, c is our constant. So you are getting the idea. So this one is the straight line equation. You can see here, like we have used this simple linear regression model. Why is it so? Why is it simple and why is it linear? Linear because it is following up the straight line equation. Okay, that's why we are using this linear term. Linear means when it's following up the straight line equation. Okay, and simple, why is it simple? Because in this particular example we have considered only one independent variable, that is price. If you are having more than one independent variable, suppose price, income, let's see this example, price and income, then we are calling it multiple linear regression model, MLRM, multiple linear regression model. And when we are having only one independent variable, we are calling it simple linear regression model. Okay, so now I'm going to explain each term of this equation. Now this quantity is your dependent variable. What is B naught or beta naught? Or you sometimes you can get alpha. Okay, in your straight line equation, you can see it in C, right? C is there to depict the constant term. Anyway, so this B naught or beta naught is actually the constant part, and it is showing you the intercept part. Here you can see this is the intercept part, right? Y-intercept part. So this constant part is telling you the intercept part. But this is very mechanical, right? You need to know that how to explain it in simple words. Because in interview, if anyone asks you that, see, what is beta naught? Can you explain it? If you only say this is the constant term or y-intercept, they will not be pleased. So they want you to explain it. So how will you explain? So let me give you the example. Suppose we are having income and consumption. Okay, both are correlated and both are positively correlated. It is expected for normal goods, if income increases, consumption is also increasing, right? Now if your income is zero, suppose I lose my job, then my income would be zero. Then also I need to consume something to survive. So when my independent variables value is zero, then also I might have some positive value or some value of my dependent variable. So this intercept term is telling you that fact. It is not depending on your independent variable. If your income is increasing or decreasing, this intercept term's value would not get changed, because it is telling you that if the independent variables value is zero, here if my price is zero, my product's price is zero, what would be the demand? If you see this equation, if your price is zero, the demand for the product would be suppose 2000 units, okay, or 2 units. So this is what the intercept term. When your independent variable's value is zero, what would be the value of your dependent variable? The intercept term is telling about that particular thing. And in this way, you have to explain it. If you only say it is a constant term or y-intercept in interview board, they would not be pleased. So you have to explain it in simple way so that they can understand that you have the idea. Okay, because y-intercept and the constant you will get from anywhere. But if you have the knowledge what is it, then only you can explain it. So guys, is it clear how to interpret this intercept term? It's important. Okay. In model, we usually don't consider it. Why? Because, okay, Hassan, sorry. See, actually, we were talking about the intercept term. So intercept term is what? It is telling you if the independent variable's value is zero, what would be the demand for your product? As an I'm actually explaining it for you. If suppose here we are having the independent variable price, and if the value is zero, then also you might have some positive demand for your product. So the intercept term is telling you that fact. If your independent variable's value is zero, what would be the value of your dependent variable? That is what your intercept term. Now practically the client is not so much interested about this intercepts value. Why is it so? Because they want to know what independent variables are affecting their product's demand, so that they can influence those independent variables and can increase the product's demand or the sales or the profit. right? So if the independent variable's value is 0, so that means this the client have no power to control that intercept terms value. They have no power. Like if the independent variable's value is 0, what would be the demand? I mean, knowing it, what they will do? Obviously, they always want to increase the profitability. They always want to maximize their sales. So that's why they always want to know which are the factors or independent variables affecting the dependent variable, so that they can influence those factors and they can take some strategy to maximize their profit. So that's why the client is more concerned with this independent variables part, the slope part, what we are going to discuss now, not with that intercept part. Okay, now let's come to the slope part. What does it mean? It means if price increases by 1 unit, the demand would be decreased or increased by how much? If you see this equation, so minus 1.5p, this minus sign is telling you that they have a negative relationship, means price and quantity, they have a negative relationship. That's why this sign is negative. Now what is 1.5? This is the slope. Now if price increases by 1 unit, the quantity demand would be decreased by 1.5 unit on average, or you can use the percentage term as well. If price increases by 1%, the quantity demand decreases by 1.5%. Okay, this is what your slope term. This is how you have to explain your slope part. Okay, and it's actually telling you the magnitude of change, and if you plot the value of p here, then you will get, you can predict the value of quantity demand as well, isn't it? Right? So this is how you have to interpret the slope term and the intercept term. Now next part is this error part. What is it? We didn't get it in our straight line equation. This is something new what we have added in our regression equation, right guys? So what is it? See, let me give you one example. See, GST is coming. So if suppose last year when I developed my model, I had no idea about the demonetization, or I have not considered the GST part in my model. But you people know that these things have a, I mean, great effect in your market, right? In your product's demand. But we have not considered it. Suppose last year or 2 years back, I developed the model, and that time I had not considered the GST and my demonetization part. And so many other socioeconomic factors might be there, which I have not included in my regression equation. But we all know these factors have a great impact on the demand, on the products market. So what we have done, we are calling these factors as external factors because these are not included in my equation. So we have summing up all those factors effect, and we are putting E in our equation which is indicating those external factors effect on my dependent variable. Here in this equation, we are calling it error term. Have you got my point, guys? So many factors are there which we have not considered in our equation, but they might have a significant impact on our dependent variable. We have summed up all those factors effect, and we are putting this E, which is the indicator of those factors effect on my dependent variable, and this is called error term. And let me tell you, as because these factors are not included in our regression equation, our client has no control over these factors. Okay, so we should have less number of external factors as much as possible. Okay, so that most of the part or most of the variation of our dependent variable can be controlled by the independent variables what we have considered in our regression equation. We don't have to depend on those external factors on which we have no control. Okay, so have you got my point, guys? Have you got my point? This regression part, this is very, very important. Okay, only to answer. Hare Krishna, Vartika. Okay, thank you. Vasudev, it's clear? Ashish? Vasudev? Okay, thank you. Thank you, guys. So let's take 5 minutes break. So from 11:20, we are going to start our new topic. Today we are going to discuss the sampling, the hypothesis and testing. Okay, that is very, very important. Okay, and critical region. And then we will finish our class. So let's take 5 minutes break. By 11:20, we will be back. Okay, Vartika, that means you will leave by 11:30, right? Okay, so by 11:30, obviously I can't finish all those topics. As Saji told you that, the videos are available. The link would be provided to you. So please check it. And let me tell you guys, 2 links are there. Okay, in Facebook and in Quora. Please click on it. Please leave your reviews. It actually matters for us. Okay. Did you like the session or not? And if you want to suggest anything, okay, you are most welcome. Please use those links. Okay. So guys, so now the topic we are going to discuss, that is sampling. See, why do we require the sampling part? Always I'm using the sample or the data set what you are having. See, population size means, suppose if I want to calculate the average income of Bangalore's population, okay, or Kolkata's, or Delhi's, or whole India's. So is it possible for me to go to each and every individual and then collect the data? Because the size is very big, a large data set, right? So it's not possible to consider the population in your analysis. That's why we are using the sample part. Okay, randomly or in some other method, we are collecting the data from some observation from some individuals. On the basis of that, we are going to analyze something, and we are going to say that, see, on the basis of my sample, I have got this conclusion, and it is expected that in population also the same features you can see. Now, let me tell you that that's why we always want to get a good sample. Sample should be a good representative of your population. If we have not got a proper sample or good sample, that means on the basis of that sample, the decision I'm going to make, that would not be proper one or the correct one. So every time, that's why I'm telling you, we should understand the data structure, the samples first. Okay, so that we can have a clear idea that whether the conclusion I'm going to get using this sample is a good one or is a bad one, that we can imply on the whole population or not, that can be generalized or not. So that's why this samples part, the sample structure part, is so important. Okay, now for population, if we are having the average or the standard deviation, this type of measurements, we are calling it parameter. And if we are calculating the average of our samples or standard deviation or kurtosis, whatever, of our sample, we are calling it statistic, not statistics. S is not there. Okay, statistic. Now, when you are getting okay, simple random sampling, stratified sampling, systematic sampling. So I included these two famous one. Even if systematic sampling is also famous, systematic sampling means suppose they are collecting data, they started from the first house and then they will leave two house after that, and then again they will take or collect the data from the fourth house. So they are just leaving two house between these two houses. Okay, so systematic way, or suppose if the customers are coming out of the stores, first one from the first customer I will ask some question, second, third, fourth I will leave, from fifth one I will again ask some questions, again three customers who are coming out, not going to ask them anything, then again the next one I will ask. So it's a systematic method. So another one is simple random sampling. What is that? I have so many students in my class, right? I can ask question from any one of them. So everyone in this class or in this session is having equal chances to get selected. Okay, no one knows who is going to be selected. Everyone is having the equal chances to get selected. So no biasness is there. So that is what our simple random sampling. What is stratified sampling? Suppose in a particular population, you are having some feature present in university. Okay, you get to know that the students who have taken statistics from last 10-20 years, the 60% are male, 40% are female. Okay, so obviously from last 10 years, so many students have gone through this session. Okay, they have completed their courses and they left, so I can't reach to each one of them. So what I will do, I will collect the sample from my present students, and what feature I have got, that 60% were male and 40% were female. So in my sample also 60% should be male and 40% should be female. The feature what we have in our population, in my sample also the same feature should be present. So that is what our stratified sampling part. Suppose when you are collecting the sample, you want to, you have some objective that you want to know what is the average income of suppose Delhi's population. Okay, now you are collecting the sample. Now from first sample you have got 20k, from second sample you are getting 30k. Okay, So what is sampling distribution? If you consider this 20K, for how many samples you will get this 20K? What is the possibility, or what is the probability that from the next samples you will get this 20K value? Okay, so this is what your sampling distribution. In samples you might get so many values. For a particular value, if you say that what is the probability that other samples will take the value 20K. This is the probability distribution of your sample values. That is what we call sampling distribution. What is standard error? What we discussed last day, that what is standard deviation, right? So standard deviation we use for the population. Okay, in similar way, for the sampling distribution, if we calculate the standard deviation, we are calling it standard error. Okay, so we have a samples, we have a sample values, and we want to know that what is the probability of getting a certain value of a sample, suppose 20K or 25K. So there we are having a sampling distribution. If we calculate the standard deviation of that sampling distribution, we are calling it standard error. Naturally, in model, what we want to check, looking at the standard error, what we will interpret? Looking at the standard deviation, what we interpreted, that if it is close to zero, variation is less, better for your model. In similar way, if we look at the standard error, and we always want to get standard error minimum, close to zero means less variation, better for your model. That's the thing. Okay, so standard error means it's also telling you about the variation. If less variation is there, that means that is a better for your model. So it's always better to have standard error close to zero. Okay, so that means it is the conclusion or the decision you are going to make on the basis of that sample is going to be a good one, because the fluctuation is less, the variation is less, the standard error part is less. So in this way you can use this standard error concept. Got my point, guys? This is what you have to understand. The formula you can say after that, but the interpret or the how to interpret the result, that you should know. So this is how you can interpret the result. Just like your standard deviation, if it is close to zero, less variation, better for your model. In similar way, if standard error part, the value is close to zero, less variation, better for your model. No hard and fast rule what should be the value. Obviously, if 10 you are getting, if 20 you are getting, obviously it's not good. Variation is very high. So you need to take care of that matter, or you have to increase the size of your data set so that you can reduce the variation within your data set, and you can get a better result from your standard error part and standard deviation part. So clear, guys? So this is what you're sampling. Okay, let me know, guys. Then we are going to start our new topic, estimation and hypothesis. Okay, Hassan, thank you. Vasudev, Hari Krishna. Okay, Jishan, thank you. Vasudev, Hari Krishna, Ashish. Yes, Ashish. It's not for only linear model, it's for logistic model as well, but for any kind of model. In time series analysis, we usually don't use this sort of things. Okay. There are some other measurements to check whether the data is good or bad. Okay, for the linear logistic clustering, we can use this one. Vasudev, is it clear? Welcome, Ashish. Okay, so let's move ahead. Now, this topic is very, very important because when we will start developing a model, every time we will find this one. What is null hypothesis? This is hypothesis testing, null hypothesis, alternative hypothesis, level of significance, blah, blah, blah. So this topic is very, very important, just like your regression part. Okay. So suppose first thing is estimation. What is that? Suppose if I tell you that estimate the value of or the estimate the average income of Kolkata's population. I have no prior knowledge. I'm asking you to estimate a particular value. Okay, and you are estimating it. Obviously, you are doing some assumptions on the basis of your sample. So you are estimating it. So it is termed as theory of estimation. I'm not giving you any value that this is this, or the value is 30K, or the value is 40K. I'm not telling you anything. I'm just asking you, see, guys, just estimate the average income of Kolkata's population. So, what you will do? Obviously, you are going to estimate the value. Okay. Now, there are two types of estimation. The interval estimation. What is point estimation? Point estimation means, suppose if you give me like the average income is 25K per month. Okay. That means you are giving me one particular value, one point only you are identifying. So that is what your point estimation. Okay. Now what is interval estimation? Tells me that the average income lies between 25K to 35K. So I'm giving a range. Okay. This is what your interval estimation. It's always better to have interval estimation, because suppose if you are giving only one value 25K, and anyhow if someone gets is 27K, so the probability of getting error in terms of point estimation is high. But if you give a range, it's 25K to 35K, so the probability of getting correct answer or it's high, right? So making mistake or getting error, the probability of getting error is less in case of interval estimation. So this much you should know from the estimation part. Now let's come to the what is hypothesis? It's about the assumption. Now I told you it's not possible for me to consider the whole population. That's why we have collected some samples, and on the basis of that we are going to assume something for our population, and we are going to test whether this assumption is correct or wrong. Okay, so always remember we are making hypothesis for population, not for sample. Okay, because if you know your population, then obviously you don't have to make any assumption. Directly you can just calculate it and you can give the exact value. But as because we are unable to consider the whole population, that's why we are depending on the sample. We are making some assumption or hypothesis, and on the basis of the sample we are testing whether this hypothesis is correct or wrong. Got my point, guys? So this is what test of hypothesis. Hypothesis means the assumptions what I'm making for my population. And what is test of hypothesis? The samples what we have collected, on the basis of that we will test whether the assumptions are correct or not. So this is what test of hypothesis. Okay. Now this time I'm going to give you a second value. I have assumed that Kolkata's population's average income is suppose 30K per month. Okay, this is my assumptions. Are you going to believe me? Obviously not, because you are going to test it whether Motrisha is right or wrong on the basis of the sample available. So, null hypothesis is the hypothesis made about the population characteristics is called null hypothesis. Okay. So here my null hypothesis is that Kolkata's population's average income is 30K per month. What is alternative hypothesis? Alternative hypothesis is just the opposite of your null hypothesis. Means the average income of Kolkata's population is not equal to 30K per month. Clear, guys? So this is your null hypothesis and alternative hypothesis. So till this, is it clear? Because next okay. Thank you, guys. So next part is type 1 error and type 2 error. What is it? Now, we are humans, right? So we can make mistake. Our mood varies. We are so upset or we are very excited. In this true extreme situation, we can make some mistakes, right, guys? So anyway, so let's take it in that way. Suppose if you have got a result which is actually telling you that the assumption you have made that is perfectly fine, that is true, and by mistake, suppose you are so upset, okay, and that's why by mistake you reject your true null hypothesis, okay, then the error is termed as type 1 error. When the null hypothesis is true, but by mistake it is rejected, we are calling the error as type 1 error. Okay. Next one is, suppose you are very excited, okay, and you have got that null hypothesis is false. The assumption you have made, that is wrong. So null hypothesis is false, but you are so excited. Okay, no problem. Just accept it. I'm in a very good mood. Right. You know, it happens in when teachers are checking students' scripts and students are getting very bad marks or getting scolded. So my teacher was in a very bad mood. That's why he just, reduced my marks. We always used to say these things, right? Or we are getting scolded, that means our teacher is in a bad mood. Or if we are making some mistake but he is or she is telling us that okay, not an issue, you try it again, that means she is a very good mood. We assume these things, right? So in this way, when you are very excited, what we can do, we can accept the false null hypothesis, right? So that is also an error that is termed as type 2 error. Okay, so type 1 error is when your null hypothesis is true but you are rejecting it. It is termed as type 1 error. And when your null hypothesis is false but you are accepting it, we are calling it type 2 error. Okay, now let me give easy example. We all know that wolf and shepherd story, right? So I have used that one and tried to explain the type 1 error and type 2 error using that story. It's very interesting, but try to understand it. Okay. First thing, whenever you are going to test anything, what you should have? One hypothesis, one null hypothesis. So here, my null hypothesis is no wolf present. This is my null hypothesis. So the opposite one or the alternative hypothesis would be what? Wolf present. Isn't it, guys? So null hypothesis is no wolf present. Alternative hypothesis is wolf present. Now consider the story. The story's first part. In the beginning, what we get to know? When no wolf was there, means our null hypothesis is true. But villagers came to save shepherd, believing that there was a wolf. Actually, there was no wolf. What is my null hypothesis? No wolf present. So in this first situation, everyone has the same problem. Guys, can't you hear me? Okay, Hassan, so you can hear me. Okay, thank you. Uh, I think Ashish is having some audio problem from his end. Thank you, Ashish. Okay, guys. So, so have you got the point? So our null hypothesis is no wolf present. So in first situation, what we got that when no wolf was there means our null hypothesis was true, but villagers that rejected it, right? So this is the example of type 1 error. Okay. Now, at last, what we see that when actually wolf was there, no one came to save shepherd. So that time when wolf was truly there, means my null hypothesis is false. Okay. Basically, when null hypothesis is false, we should reject it. But here you can see when wolf was not, when wolf was actually there, that means our null hypothesis is false. But no one came. That means they accepted the false null hypothesis. That means it is an example of type 2 error. Guys, is it clear this type 1 and type 2 error? Okay, Hassan. Thank you. Great. Others, please confirm. Thanks, Ajit. No, Jishan, it's not kill the wolf. It's they didn't came, so wolf took the shepherd. So wolf killed shepherd. Okay, villagers didn't came. Okay, so that's the thing. Okay, so as this one is clear, next is the level of significance. Okay, why it's important to understand type 1 error and type 2 error? Because when you are going to take some decision in your model that whether you are going to keep the variable in your model or you are going to drop it out from your model. Okay, you need to compare some value with this level of significance value. So that means you should know what is level of significance and what is level of significance. To understand it, you should understand the type 1 and type 2 error concept. Okay, As we are done with the type 1 and type 2 error part, we are going to discuss the level of significance right now. Ashish, I hope now you can hear me, and I can repeat the thing now only. You see the video, and if you face any problem, then you just ask me. The point is that the type 1 error, when suppose the null hypothesis is true, we should accept it. By mistake, we are rejecting it. That is the type 1 error. And type 2 error, just the opposite. The example is given over there, and you can just read through it, and I hope you will get the point. Now, what is level of significance? See, both are very crucial, type 1 and type 2 error. But statisticians, they suggest that type 1 error is more severe in nature. So in level of significance, we are considering the type 1 error part. Please don't replace it by type 2 error. Use type 1 error because it is universally accepted one. Okay. Now suppose 100 chances are there. Okay. Now within this 100 chances, how many times you have made mistake? You have made mistake means when you have got null hypothesis as true, but you have rejected it. Okay, what is the probability? What is the maximum probability of type 1 error is called level of significance. Suppose 5% level of significance. What does it mean? Means 5 out of 100 chances are there when you might have a, just a second guys. Okay, so 5% level of significance, what does it mean? 5 out of 100 chances are there when I might commit type 1 error. Means when I have got null hypothesis as true, but by mistake I'm rejecting it. If anyone tell that 1% level of significance means 1 out of 100 chances, means 99% chances are there that I'm making no mistake. 99% confident I am that I have not made any mistake. Only 1 out of 19 chances are there that I have made a mistake, that when the null hypothesis is true, I rejected it. So that is what your level of significance. For a risky project, mainly for the financial institutions, suppose on the basis of your decision or conclusion or the model, our client is going to take some very important step, like they are going to decide whether they are going to uh, sanction this loan to that person or not. This is very important, this is very crucial one, right? So there we can't take any chance. So there we will take less than 1% level of significance. It means that the chances to make mistake, it is less than 1% as well. Okay, okay, so that is what your level of significance part. So guys, till this, is it clear? Because the topics what we have discussed today, those are very very important for the development, the descriptive part as well as the advanced part. So I hope you will understand it. So guys, till this, is it clear?
Hello? Matusha, am I audible?
Yes, we can hear you.
Okay. So there was a connection issue actually. So are we still continuing with the class?
No, actually, the hypothesis part is done. So today I'm done.